Welcome everyone to the session why I moved away from Lava for RCI. Uh, basically, yeah, I mean, you just skip one. Yeah. The agenda is that I'll just explain what was the use case for RCI and the attempts we made on using Lava and where we found it, the shortcomings of Lava for us, and the current CI setup that we have, which is kind of stable, and the issues that we have with the current setup. And I want to discuss if there's any scope or possibility for us to move back to Lava. Yeah, I'll just explain the tests that we run for RCI. There are a few tests that we run on x86 machines. Those don't need Lava kind of thing. But there are tests that needs a Nexus kind of device, and for which, for certain use cases, we tried Lava. The first one is our target test, which is a set of tests that are run to validate the RVM. And this thing actually needs the build machine and a Nexus device connected to it. The second one is MicroBenchmarks, which are a set of benchmarks developed by the art team, which run independent of the build machine, and we had tried to run them on Lava. On the target tests, the use case was that these tests actually, the requirement for these tests were that the build machine expects the target to be connected to the machine, and during the build itself, it actually runs these tests. We did some investigation on running them in Lava by just compiling these tests and then packaging them in the image and then running them. But we found it was too much of effort. Since these tests are being developed on a daily basis on ESP master, we couldn't generalize them and use them, and the way we ran them in Lava wouldn't be the same we would run them on the developed machine. It was simply that if the tests were run as part of the build itself, it was much faster compared to actually building images, getting them uploaded, and then trying to run them in Lava. Those were the main reasons why we didn't choose Lava for these target tests. Instead, we got 2 build machines deployed in the lab and got the Nexus 9s connected to them, and that was setup which we were using. On the other hand, for the micro benchmarks, since they were independent of the build system, we could run them in Lava, but since they were host driven, we had to use a multi-node environment. The problem what we faced was we wanted to run them on Nexus 9, but multi-node was not supported for Nexus 9 kind of devices. For which I guess the lab guys and Lava team came up with using this NUC and the Nexus 9 combination. This was kind of the setup that we had around 10 months back, where we had Jenkins master, 2 fast Jenkins build machines, which actually did the builds, and then submitted these MicroBenchmark jobs to the dispatcher, which were running on this NUC and Nexus 9 combination. Parallelly, we had these couple of build machines in the lab, on which we were actually running these target tests. We were using these as Jenkins slaves and then running target tests. This kind of summarizes the setup that we had. Coming to the issues that we had in the lab, initial thing was multi-node was not supporting the Nexus kind of devices for which we had this NUC and Nexus 9 setup. Initially, when we had 1 NUC and 1 Nexus 9, it was kind of stable for us, but we had to scale. So we tried using 2 Nexus 9s on a single NUC, and that is when it was very unstable for us. We had multiple issues. I've tried to capture most of the issues there. one of the issues was batteries were discharging on these Nexus 9s only on the NUC setup, whereas things were quite stable on the build machines with the Nexus 9 connected. For this battery discharge issue, I mean, there were with two Nexus 9, we were having issues with device detections. That is when we came with the Cambrionics hub, which kind of resolved part of the issue. That is, battery drain issue was kind of resolved there. I mean, we did some more investigation. One of the issue there with battery discharge was the cables that we were using with these Nexus 9s were actually driving lesser current compared to the original cables. But later we were able to narrow down the issue and fix that. These were kind of the lab issues. The other things that happened due to these device detection failures, the health check jobs themselves were failing. But the device went offline only when the health check jobs failed. But there were other jobs that ran before the health check, which were actually failing due to this infra issues, but Lava was not able to capture them. And only when a health check job failed, the device were put offline. The request that I have here is if we can have some generic solution where the Lava admin can actually classify the failure as infra or critical failure. That way, device can go offline as soon as any job fails. I mean, during the execution, test can fail due to issues with the test or the image, but along with that, it can fail due to infra. If the admins can have the feature to actually classify the failure, and based on that, either Lava itself can intimate the lab guys, the admin, or put the device offline. That way, we can actually detect the failures much early and will not lose a lot of jobs. That is one case there. Other thing was we had a lot of patching on the way we try to detect the device whenever this device detection failed. That kind of adds up a lot of time in the test execution itself. Like the MicroBenchmark execution itself was taking around 25 minutes, but the complete run in Lava, that was taking around 90 minutes for us with all these workarounds that kind of kept getting added there. Yeah, I mean, these were majorly all these issues that we faced, but I would like to thank the lab guys. They were very patient enough to address the issues whenever we ping them about these regularly. Things are not very clear on this slide, but this kind of gives an idea of how many times the device was put offline and then online again in just a span of 1 month. Basically, it actually lists down the issues which I mean, Dave used to mark fast boot issue or the battery drain issue or a device detection issue that actually showed up. These were the main issues that we had, that is with respect to stability. The point that I want to get to here is we don't have a particular, we don't have any criteria or standard for a device to be marked as it is Lava ready. We kind of get the device working in the lab with one set of health check images, and if there are any failures, we don't have a certification or a set of robust tests that are run before we can claim that a device is ready to be used in Lava. Health checks are very minimal is what yeah.
Yeah, so a health check is a job, so it can actually do whatever you like. At the moment, we have a very basic health check, which is, does it boot into Android when you deploy an image? And we can make it much more complete. But actually, going back to what you were saying earlier, I think where we need to get to is that if a job, not just a health check, goes incomplete for a reason to do with infrastructure or the device, then we need to run a health check immediately to see, oh, it's gone, and then you use one job, not the next 100.
So there is a lot of support coming in V2 to address a range of these issues. Just on that thing about the critical failures, as long as Lava, even in V2, has got a sufficient way of reliably identifying exactly what has gone wrong. Now, we try our best to actually detect and determine what those failures are and make sure that we are picking it up the right way. But to actually add the support to take the device offline automatically is not necessarily the best way to do that unless we are guaranteed that that particular error can be caught reliably every time without false positives, which is why we think about running a health check.
Yeah, I mean, I agree. Running a health check and then putting offline is good enough.
So the other way of doing, another way to not lose jobs at all is it goes incomplete, a job goes incomplete. We run a health check, which also goes incomplete, so we take the device offline. If you have more than one device, we should then have some mechanism of resubmitting the failed job to another device.
Yeah, that'll be helpful as well.
So we are looking at, there's a queuing set of supports that's actually being worked on, and that it does include the ability of moving a job from one to another because of issues like that. We also have support for running health checks every n number of jobs instead of every number of hours. That's come in recently in V2. I'm not sure whether setting that for every one job it is supported.
What I'm saying is that we need not have to run on every job, but if a support is there to classify a particular error.
It's the classification that needs to be
and
so
then
reliable.
running it. You can go to the next one. Fast forwarding to the current day where we are not using Lava. This is the setup that we have, a Jenkins master, couple of fast build machine slaves. They have a SSH connection to the machines that are there in the lab, which in turn connect to a Nexus 9 and a Nexus 5X. The SSH connection between these machines will actually do a port forwarding. With this setup, the ADB server that is running on the machines in the lab actually talks to the ADB client that is running on the Jenkins slave machine. With the setup, the build machine, it appears that the build machine has a Nexus 9 connected to it, and with this setup, we are running the target test as well as MicroBenchmarks in the setup. We did some changes with the way we run MicroBenchmarks to actually run these MicroBenchmarks in the build machine during the build phase itself.
So in this setup, how often are those Nexus devices redeployed, rebooted?
I mean, with this current setup, we don't do this reboot or redeploy unless a device actually discharges or anything. But in general, we don't run into any of stability issues with this setup. And we don't, the way we've configured the MicroBenchmarks as well as the target tests, they run in a chroot environment. So we don't have to flash these images at all.
That's what I was coming to, is make, if you're doing these constantly running devices, you have to think about the persistence and the problems of one previous test, particularly if it fails halfway through, contaminating the next test. So
yes, I agree to that. The thing is that these tests currently run in a chroot kind of environment. This is sandboxed with against the image that is running on the device. That way we don't actually corrupt anything on the host, the host OS that is running on the machine itself.
So you don't redeploy the OS very often?
Yeah.
Okay, and you run everything
almost,
in a
CH root kind of
environment?
Yes.
Okay. And that is supported in V2, so that you actually don't change the OS.
Okay. Yeah, dummy deploy, if that's supported.
So it's dummy, yeah.
So in V2, we've even got the outline support for using the root directly.
Okay.
So we're actually putting that into there. But the issue, one of the issues here is Lava isn't meant for absolutely everything. It doesn't have to do all possible situations. So although we can do a lot of these things, it's also a question of whether Lava is still the best solution for you to go back to afterwards. That's still something that you can think about. We don't have to use it this way, and we can try and help you as much as we can. The main benefit of doing tests like this in Lava is when one of those devices fails, or when you need multiple devices, or when you start adding in more complexity on that level, then it's much easier for Lava to actually just move on to another device or to parallelize things. So when you've got a number of devices there, you can run tests on a number of devices at the same time. But if you're serializing the whole thing and you're relying on fixed machines that don't essentially change much.
Yeah, the thing is, that is where I'm getting, those are the issues that we have with current setup.
So we actually did in Lava V1 implement a similar solution for the OpenStack testing, because what we have is there are three, in this case Mustangs, in the lab for OpenStack. They have two device types associated with them, one of which is dummy Mustang and then Mustang. And the dummy Mustang means you don't reflash the OS. You just always, you're booted into it, you can just do what you like, and then when you really do need to reflash the OS, use the Mustang device, which actually will do the whole thing because you need to update it or whatever. Okay. And that actually worked. It worked really well. So I think we could come up with a solution like that for art that does a similar thing, where you go, well, actually, most of the time, I don't need to reflash everything, and I know I'm protecting myself, I know I'm good. But periodically, or something's gone wrong, or you need to update the OS. Yeah. So you need a way of doing that, and that's when you use the straight-through device. Yeah.
That is what I was getting to. The current issues that we have is we have the static map of two build machines connecting to two machines in the lab which have a particular Nexus 9 connected. The reason we have this issue is there's a bug with ADB where we can't run multiple ADB servers on the same build machine, which is again solved in Lava V2 with using containers and all these things. That is where I feel directly using one solution which is already done in Lava V2 will be actually dog fooding and doing more testing rather than we doing another solution and using it at our end. Those are things that the current solution doesn't scale well. We plan to have a few more Nexus devices added, the ones that get released next month, and that is where, as you said, we rather than having the static map, Lava can give us the device from the pool, whichever is available.
So you don't have battery problems or those kind of things anymore?
No, not at all. Though the battery issues were related to, one, the cable that we were using, and the second, the NUC was not driving enough power on the USB 3 port.
And we were running into the reboot loop.
Yeah, reboot was actually giving us the device detection issue. We were never knowing that whether the device was in fast boot mode or in user space mode.
No. What I'm saying is that there were images that we flashed on the boards that resulted in rebooting in a loop.
That was very rare, is what I would say.
Not really.
And I'm pretty sure because
Not really.
ASP Master, we were tracking things
Whenever I went to the lab, it was rebooting in a loop.
yeah, maybe
No,
we don't
that,
agree
that
on that,
happened
but
a lot. Now, there were some images going through. I don't know where they were coming from, but they were.
yeah, I mean, I know that
the point is that the way you want to use it with art at the moment is that you, if you had this dummy deploy. Effectively,
yeah,
you had the OS there, and you know it's a solid OS, and therefore you don't update it all the time.
yeah,
Then you're going to have a lot more reliability.
yeah,
And that is what we saw at OpenStack by putting that kind of method in, by having these two
yes,
parallel device types.
It also means that your test runs a lot more quickly because you're not having to
Yeah.
go through the
Yeah.
deployment stage.
yes, that
And you're
is
not
the thing.
deploying something that might be dodgy,
Yeah,
might break
yeah,
the
that
device.
is the thing.
You're just, so
Yeah.
all of these things are solvable in V1 or V2 actually, but V2
Yeah,
would be
yeah.
preferable.
Another issue that I faced was with Lava test shell. I mean, this is no more relevant in V2, but again, one issue with Lava test shell was it actually needed a reboot across every execution, even if it was not mandatory for us, the actually test runners. That device had to be, yeah.
So that's the point of V2 is that you, as the test writer, are in control of that.
Yeah, I mean, I just wanted to say, I mean, I know that in V2 we don't have to face that issue.
So are you coming back to the dark side at some point?
We are actually willing to actually use Lava V2 with all these things. That is where the end goal of this session was.
But that's useful because we've got some Nexus devices still on staging, Dave, haven't we? And we can set up this kind of thing and actually proof what we
Yeah,
have.
I mean, if we can start working on, if you set up it
Particularly
on set.
Particularly with having one device in a primary SSH connection and the other one as a standard fastboot deploy type, and running through on that.
I think in order to not deploy images to Nexus devices and deploy occasionally, we also can try something like you have a LXC container and then show the device to the LXC container, and you don't have the deploy action at all, and you you get rid of the boot. You just have the boot action.
I mean that also works as long as deploy and boot are not mandatory commands.
So I mean, instead of having dummy devices, you can still use the LXC containers in order to do that.
The big advantage with the LXC is that it is a normal Lava test shell on the dispatcher in a container, so it's got all of the resources you need there.
Yeah.
There's a lot of stuff you can do when you think that actually what you've got there is a fully functional operating system. You can do lots of neat stuff inside that container, as well as just pushing the ADP stuff.
Yeah.
Sorry, I was just going to add, one of the things I think we need to consider for art project is that we make it a micro instance, so it's under your control in terms of when you redeploy images, when you want to deploy new images, that's your control. That's what we did for OpenStack as well. So.
Yeah, I mean, it's not very critical, but if you suggest that it's going to help us better, we're okay with it.
Well, we've got, I mean, like you said, it doesn't scale and it's not cost effective.
Yeah.
You've got quite a lot of hardware there supporting a handful of devices. So.
Yeah. I mean, one more thing with the setup is the port forwarding thing that we need, the bridge that needs to get set up from our machine to the container. That is something I don't know. It falls under the lab guys' work or in the.
A lot of what we've been talking about so far was for the MicroBenchmarks. For the build machine, yes, we might have a different thing to think about how we actually get the connection into the LXC. So that needs some time to prove that out and see how we actually get that working.
So it seems that a lot of issues revolve around the fact that you're plugging a phone into a build machine. Would it be possible to use something like a Juno or a Hikey to run these tests that would eliminate a whole class of problems? Or
No, because I mean, it's a requirement from the development team. They actually, I mean, they want to submit these patches to Google, and Google uses only these devices to actually check the benchmarks.
so it's a hard requirement to use Nexus devices.
Yes.
Right.
Yep. Yeah, that kind of concludes the discussion that I had. All looks good. Lava guys are helping
So
us.
I think we need to, as Neil said, we can set up the environment for you to start this testing, to start creating the test suites in V2. We've got Nexus devices we can deploy into a contained environment, so we can actually start bringing you back to the dark side.
I think in this whole setup, we still need to solve the SSH connection thing.
From MicroBenchmarks. We can start from MicroBenchmarks, see if that works, if the stability issues are there or not. And then
The thing is, if we use MicroBenchmarks, then we'll have to change the way we run the test. I mean, we'll have to build images and then flash them every time, and then run the MicroBenchmarks.
But okay, I'm missing the link here because they are run in CH root, right?
Yeah,
Aren't they?
I mean, either flash them or we package the CH root environment from the build, and then I mean, upload and then download and then push. It's still doable at our end.
Yeah, but what I'm saying is that MicroBenchmarks don't
Yeah.
require ADB connection outside. Right?
Yeah, that is true. I mean, we can start with MicroBenchmarks.
And for the theory of getting a SSH connection into the LXC to operate things within the LXC, that's something we can test independently, and we can develop that on completely outside
Yeah,
of because
yeah.
just see how it works.
Yeah, and the point here is that V2 is not finished. So it's being developed to try to address lots of different issues.
Yeah.
And this is the sort of issue that can be added, the sort of solution that can be added into V2. I mean, it's not a million miles away from where we are.
Okay.
I mean, is there a possibility that we move the build machines inside the lab network? Like, why do we have that outside of the lab network, and we need to deal with all these SSH? I mean,
It's, I mean, cost, I guess. I mean, I'll let Fatih give more detail on that. I mean, the thing is, it's not just the build machine, the bandwidth associated. I mean, if we try to do the builds from the lab, the bandwidth won't be sufficient for us. A couple of build machines are in the lab. Those are the slower build machines, but we need fast build machines. So that's what we use from Hetzner.
Well, the summary is that we need more bandwidth in the lab because we have a lot of Amazon cloud, and if we push more builds happening in the lab.
So I've got, at the moment, what I've got into the lab is 100 meg on a 1 gig line. So if bandwidth is an issue, then, and I've been looking at this, I watched the daily usage graphs, and we are hitting that limit regularly. I mean, during a day, we're probably hitting it about 50% of the time, we're hitting the roof. So we can go up to 1 gig. I don't know what the cost is, and I'll find out and then make Rob Booth faint. But we can go up to 1 gig, which is a pretty, I think should be pretty good. But we can also shape that to some extent, so we can actually allocate certain amounts of bandwidth to different subnets in the lab. So, I mean, TCWG used to be huge amounts of bandwidth, and then we brought a lot of it in-house. And now, we just need to profile the various subnets within the lab and then say, well, okay, you need 100 meg here, you only need 20 meg here or whatever, and then just make sure that the appropriate bandwidth is available.
So some figures on exactly what you're currently using would be useful for that.
I mean, we can optimize a bit on the bandwidth requirement by having a local mirror and using that. But that is fine. The build machine procurement is the other thing.
Well, I think the point is we can look into it. We do also the toolchain working group CI, and we have already some issues on the bandwidth. So I want to be conservative in this front.
Yeah, and if you look at the number of devices now in the lab which are all pulling from the outside world, it's the more it grows, the more bandwidth we need, which is one of the reasons I went over to a dedicated fiber line for the lab, and we have the bandwidth available if we need it. What I can do is possibly negotiate with Zen, the ISP we're using, and say, can we, when people are needing to pull lots of data, can we up the bandwidth for the time that they need, and then drop it back and have some sort of cost-effective model? I don't know, but I'll talk to the ISP.
How much of what we are pulling from the outside world can reasonably be mirrored proxy? Because there are obviously files that change all the time, right?
Yeah, the thing is, on Android side, a clean build would need around 100 gigs to be downloaded. But if we mirror and use it, yes. And no, the thing is, if we use a mirror on every incremental build, it could be very less. I mean, less than, depends on less than 100 MB. And if any toolchain gets updated, it may jump a bit.
Yeah, we have a machine, a Xeon with 20 cores, and we need at least 30 gigs of RAM, 32 gigs of RAM. Yeah, that's about it.
Yeah, we can look to Esner machine because we have Esner machine for now for build a machine. I think we have one of the most powerful Esner type of machine that we have, and we still need to be cost effective. So buying such machine, we need to we need to look into it really.
Yeah.
I guess, I mean, if we can summarize this and agree on action items, that will be helpful.
Well, actually, I have only one action, so basically we want to prototype with Lava V2 some RTI micro instance and see, well, start with the micro benchmark and see where we go from there.
And I need to get a profile of the data usage in the various subnets in the lab and probably up the bandwidth. Okay.
Thank you, guys.